Hello everyone. Today we are going to discuss addressing modes. So the content of today's video is, first of all, we will study about addressing modes and then types of addressing modes. There are different types of addressing modes. We will study and discuss one by one. As you all are aware that microprocessor executes the instruction and it executes one instruction at a time. Each of the instruction contains operations and operands. What is the meaning of operation and what is the difference of operand? Operation is the task which is going to be performed like add, subtract, move, increment, load and store. Whereas operand is the data on which the operation is to be performed. Operands can be placed either in the processor register or in the memory. Means we can store the operands in the processor register or in the memory. There are different ways to get the operand. Now, how can we know that the content, like if this is a register R and there is some value X, then how can we know that is the X is the operand or X is the address of the operand? Now, to know this, we have the technique that is known as addressing modes. Okay, the way in which the operand is taken from the register or memory is known as addressing modes. Types of addressing modes. Here we will discuss about 8 different addressing modes. Immediate, register, register indirect, register addressing mode, sometimes called as direct addressing mode. So this is register direct, register indirect, direct. This direct and indirect belongs to memory. These belongs to register and these belongs to memory. Then relative, indexed and base. These are known as calculative. Calculative addressing modes. Why calculative addressing mode? Because these three addressing mode can be obtained after performing some calculation. These five are the basic or the base addressing modes. Okay. And these three are the calculative or the displacement addressing modes. Calculative, or we can say that displacement. Why displacement? Because here we need some calculation to get the effective address of the operand. Okay. Now first we will discuss immediate addressing mode. As its name suggests, immediate means the operand is specified within the instruction only. The operand is specified within the instruction only. Also, operand itself is provided in the instruction rather than its address. Means in the instruction we have the operand itself. We have the operand itself. Like here the example is MVI A, 15H. Here H belongs to hexadecimal. This H belongs to hexadecimal means this is a hexadecimal number. A is a processor register. 15 is the operand. 15 is the operand and MVI stands for move immediate. MVI stands for move immediate. So this instruction means that 15H will be moved to A. Okay. Here 15H is the immediate operand. 15H is the operand which is moved in the register A. In other, ADI3EH ADI belongs to add immediate. ADI stands for add immediate. And here the data is 3EH. When there is only one operand specified, then the by default operand will be accumulator itself. So in this case, accumulator content of accumulator will be added with 3EH, and the result will again stored in the accumulator itself. So this is immediate addressing mode. Next is register addressing mode or register direct addressing mode. Register addressing mode or register direct addressing mode. In this case, the operand is specified within one of the processor register. Means the operand is not in the instruction, it is in the processor register. Okay. Instruction specifies the register in which the operand is stored. Instruction specifies the register and the operand is in the register itself. Let's take an example. Move CA. So operand is in A and destination is C. So content of A will be moved to C. A is the operand specified in the register. So this is the register addressing mode or register direct addressing mode, in which the content of this register is directly transferred to the destination register. Another example is add B. Here we have only one operand, so another operand is by default taking as accumulator, which is a by default register. So content of B will be added with the A and the result will again stored in the accumulator register itself. Next is register indirect addressing mode. Register indirect addressing mode. Previous one was direct. Now in this case it is indirect. The difference between direct and indirect addressing mode is that in this case the processor register, the instruction specifies the register in which the memory address of the operand is placed. In the direct case, instruction specifies the register in which the operand is placed. Now, in case of indirect, instruction specifies the register in which the memory address of the operand is placed. It means in this case, M. M is the memory location on which the operand is placed. M is the memory location on which the operand is placed. So we can get the address and then the operand. First of all, we will get the address and after that we will get the operand. That's why it is known as indirect addressing mode. It do not specify the operand itself. Look, it do not specify the operand itself, but its location within the memory where operand is placed. So, as it is clear that we will get the location only. First, we will get the location and then from that location, we will get the operand. That's why it is known as indirect addressing mode. Register indirect addressing mode. Next, direct addressing mode. Now this addressing mode belongs to memory. This addressing mode belongs to memory. The instruction specifies the direct address of the operand. Instruction itself specifies the direct address of the operand, means we can get the address of the operand directly. Like the instruction specifies here LGA2805H, means that this is the address of the operand. So LDA stands for load accumulator. So we will load the content of this address, this memory address into the accumulator. It loads the data from the memory location 2805 to A. Okay. The memory address is specified where the actual operand is placed. Memory address is specified where the actual operand is placed. Okay. Now, another case is 2803H STA, store accumulator. Now, in this case, what will happen that content of accumulator will be stored at the specified location directly. So here the specified location is 2803. So content of A will be stored at 2803. Clear? Next, indirect addressing mode. This addressing mode also belongs to memory. Okay. Direct and indirect. We have discussed about register direct and register indirect. Okay. And now memory direct or memory indirect. In case of direct, we will get the address directly. Now, in case of memory indirect, we will get the address of the location on which the operand is placed. See, instruction specifies the indirect address where the effective address of the operand is placed. Now, what is the meaning of effective address? Effective address is the address on which the actual operand is placed. Means we have lots of addresses. So how can we calculate the effective address? Effective address is that address on which the operand is placed, actual operand is placed. Okay. In this case, in this addressing mode, we will get the address of the effective address. We will get the address of the effective address, and on the effective address, again we will move to the operand. The memory address is specified where the actual address of operand is placed. Means we will get the address of the operand, not the operand directly. We will get the address of the operand. Okay. Example, move A, 2802H. 2802H. Now in this case, 2802H is the address on which the address of the operand is there. For example, like this is a location 2802, 2803, 2803. इनडायरेक्ट के केस में, in case of indirect mode, what will happen? We will move this address to the accumulator. On this address, it will get the address of the operand like this, and on this address we will get the operand. So X will be the operand and 2803 will be the address of the operand, and in case of indirect addressing mode, we will place the address of the operand. It moves the data from the memory location specified by the location 2802A. Now see, here two brackets are there. Here two brackets are there. These two brackets shows that 2802 is an address and the content of 2802 is further an address. In the earlier example, there was a single bracket, means only single address is there. In this case, double address is there. Okay. Next is relative addressing mode. Relative addressing mode. Now, this is a displacement addressing mode. Displacement means calculation based. Calculation based addressing mode. Calculation based means now we need to calculate the effective address of the operand, and the mechanism through which we will calculate depends on the name of the addressing mode. As it is relative addressing mode, so in this case, the contents of program counter register. Program counter is a register. So contents of program counter register is added to the address part of the instruction. Contents of program counter register is added to the address part of the instruction to obtain the effective address. So in this case, the address part of instruction is added with the program counter and it will gives the effective address of the operand. The address part of the instruction is called an offset. This address is known as offset, which is provided in the instruction itself. When the offset is added to the program counter, the resultant number is the memory location where the operand will be placed. Next is indexed addressing mode. In this case, effective address is calculated with the address part of the instruction and index register. Address part of the instruction is again known as offset. So in this case, offset is added with the instruction register to obtain the effective address. See, content of index register is added to the address part of the instruction to obtain effective address. The address part of instruction holds the beginning or the base address is called as a base. The index register holds the index value which is always positive. Now see, in case of index register, the value which is holded by the index register will be positive always. Base remains the same, only index will change. When the base is added to the index register, the resultant number is the memory location where the operand is placed. Means after getting this calculation, we will get the effective address and on this the operand is placed. The last is base register addressing mode. In base register addressing mode, contents of base register is added to the address part of the instruction to obtain the effective address. Means effective address is calculated with the address part of the instruction and base register. If address part of the instruction is again offset, so we will add the base register content and offset to obtain the effective address. And effective address is the address where the operand will be placed. It is similar to the indexed addressing mode except that register now is called base instead of index. In the earlier case, we have used index register, but now we have used the base register. The base register holds the beginning or the base address. The address part of the instruction holds the offset as we discussed. Offset remains the same, the base changes. When the offset is added to the base register, the number is the memory location where the operand is placed. So this was all about here addressing modes. These are the references for the slide which I have just taught you. Here I took the references from Gonker and Rafiq Usman. These two books I have referred for these slides.